Thank you, everybody, for joining us today. I'm going to start off, go for about the next 40, 45 minutes or so, covering some different tips and tricks that we've come up with along the way. Myself and my colleagues, we do a lot of coaching these days and helping folks on projects. And once they've had some training in the software, now they're trying to apply it, and we're trying to do what we can to help them out and keep those projects running smoothly. So what I'm going to do is I'm going to go through some of the questions that have come up over the last year or so of us doing these coaching sessions. So first one here, this came from an agency. A lot of folks are still working kind of a hybrid work schedule. They're in the office some, they're at home some, they've got probably completely different screen setups, maybe even different computers in both places. And folks have started running into questions about how do we handle like the tool settings windows or some of the other dialogues coming up on the wrong screen, or I can't find them at all, what's going on, that sort of thing. So a couple of tips there. PopSet has actually been around quite a while in MicroStation. So if you enable that for the tool settings window itself, and specifically, you can hit Control Spacebar and bring that window up to the front of the screen for you and kind of help you out there. And so it works well if you kind of misplace it, or if it's just barely off the edge of your screen, you just can't grab it and move it. But that doesn't really work with our OBM custom windows in that, like the Bridge Wizard or Beam Definition window. So for those custom windows, for OBM specific windows, you can go to this little drop down here on the Home tab, go down to Window List, and then it will show you a list of all the windows that it knows are open on various screens. And if you double click there, that'll give you the ability to move that Bridge Wizard to the same monitor as the main OpenBridge application window. Now, for other things that may not take effect, like the primary one I can think of here is the preview window for our reports. We use kind of a little third-party app to be able to preview those reports for you. So if it's not something that OBM recognizes right away and not in that window list, like this report preview button, you can hover your cursor over the app in the taskbar, wherever you have that, and then right click on this window when it shows you all the different little previews here, and then pick move there. And that should allow you to move it, or maybe even maximize might be all you need to do to be able to see it somewhere else. All right, next up here, when do I use a roadway alignment? All right, you see that option there right when you're starting out a project. You go to add a bridge, and everybody's like, well, yeah, I have a road alignment. But if your road and bridge alignment are the same, you don't really need to use those toggles at all. So then the question becomes, well, when would I need them? Well, if you're modeling a straight bridge on a curved alignment, it can be very handy. Your longitudinal deck slope isn't the same as the profile grade of the roadway alignment. And that's probably going to happen like when the roadway alignment is out here in the median and the bridge alignment isn't parallel to the roadway alignment. Or this is also handy when the stationing differs between the road and bridge alignment. You might want all your reports to give you the stationing along the roadway alignment, which would be the second toggle here. But you're really laying the bridge out along the bridge alignment. Just remember, the bridge alignment is the one that has to have the profile grade on it. It has to have an active profile. We're only using the roadway alignment potentially for stationing purposes there. All right, speaking of stationing, this just came up last week on a call. Somebody had a situation where the support line, when they placed it, wasn't matching up with the referenced geometry from the roadway folks. So they would go in there and put it at let's say an exact station, something plus 0, and it didn't match up with what was being referenced in. It was just a little bit off, but it was noticeable. And what we figured out is the seed file that we're using for the bridge modeling was an old seed file that we had. And the degree of curve method and the curve length were not set properly. So this is in the design file settings. So you go click File, Settings, File, Design File Settings. You'll get this window. If you go to the Civil Formatting category here, double check these two and make sure they're correct. And in their case, they were in fact different, and that's what caused the issue. All right, another one that comes up quite a bit is having, or the need to have, support lines parallel to each other on a curved alignment. So folks have asked, okay, what's the best workflow to go about doing that? Because you're probably trying to keep your beam lengths the same and your span lengths constant and so forth. So how do we go about doing that? What I typically do is usually you'll know a skew angle for a particular support, whether it's the very first one, the very last one, maybe a middle support. You know you want that at a certain angle to the alignment itself, and you want all the others parallel to that. Well, we do have a parallel tool, but it doesn't, if you have a pretty sharp curve, probably not going to be a great way to go. So the other option is just place that one support line with the skew angle, then hit go back and select that support line, and in the properties window you'll see a direction field there, and we can use that direction when we go to place support lines, because there is a direction mode here, and this can be set to skew or direction. The default is skew, but if you do set this field to direction, then you're given an additional toggle down here that you can turn on and input that direction, and then all of your support lines will be at that exact same bearing or azimuth, however you have your design file settings set. All right, next up here, what about station equations and support lines? I had somebody trying to type in a station one time, and it assumes a region 0 if you don't input a station there. So again, if you don't input any region or anything, it's going to assume 0. So for notice, when I click in here, I type in a station and I hit tab or enter, it's jumping to a completely different station. But if I put the region afterwards, I can force it to honor that region and the stationing not change on me as I type it in. All right, what happens if the station of one of the support lines, you want to change it? All right, is there a quick way to adjust everything else? Yes. So assuming you're holding all those span lengths and everything, the Modify Support Line tool is going to make this pretty easy for you. So you'll open up Modify Support Lines. It'll show you the current station, the angle, the span length, and the length of each individual support line. You can change any value in this station field right here. It'll hold the span length and adjust all of the subsequent stations here. So what I did is I changed my station for support line 2 from 40 plus 00 to 40 plus 50. Then you'll notice that added 50 to the other 3 support lines here. All right. Now, one thing we're not used to, or we're hopefully getting used to, is using the roadway geometry live as we do all of our bridge modeling. And that makes folks nervous. They're not used to doing that. If anything, you may have gone out and grabbed at most maybe a GPK file or an ALG file in the past, or an XML file, and imported in some geometry and just started using it. And the problem with that is it was just a snapshot of what was in that file at the time. And if any changes were made, there was no mechanism to notify you and let you know that a change had been made, either horizontally or vertically, to that alignment. So the good news is, if just the stationing gets modified, all right, nothing else changes, the next time you open your bridge model, it always compares what it thought the geometry was, or what it last knew the geometry as, with what it is now. And if it sees that the stationing has changed, all it does is updates the station values of the support lines. That's it. Nothing else. The bridge doesn't move or anything else. So you're good. One tip, always keep your 2D geometry reference attached and displayed, because again, that's what we're using to read the horizontal geometry and the vertical geometry of the profile grade line. The 3D geometry, purely optional. I tend to turn it off more often than not. It's not really helping you out. Everything we're doing is based off that 2D default geometry model. All right. Next up here, and I'm not even sure if this is documented out there or not, but we've talked about it a little bit in the past on some of our webinars and that. But you can use construction class elements in your deck and barrier templates as kind of an aid to do certain things. So, for example, to get this drip edge correctly in here on this particular deck template, I used a construction line to do that. So when I drew up the template initially, I had to tell the software, hey, I want to draw a construction line. I actually purposely made them blue just so they kind of stand out here. And when it imported that template in, it creates all these points, C points, at the end of each of the construction lines, C0, 1, 2, 3, 4, and so forth. But notice what I was able to do here, and let me pause this for a moment, is, for example, for point 17, which is this guy right here. The slope of this is going to be different on every bridge. For this little piece right here, it depends on how wide is that fascia distance and how deep is the haunch on the beams and that. So this is going to be constantly varying. So there really wasn't a simple way to put in just a horizontal and vertical, or a horizontal and a slope to go maybe find the location of these 3 points here. But with this construction line here, what I was able to do is use a horizontal and an offset constraint here. Horizontally, I said it's looks like it's 4 inches over from the edge of the deck, but it's at a 0 offset to this element right here, the C0 to C1. And then I was able to do the same with the other points that make up that drip edge. So if we look at point 16, for example, it was 3/4 of an inch over from 17, and also 3/4 of an inch above that line. And then lastly, point 15 was about the same as 17. I also used that actually just this week. Construction elements, construction class element on the back of a barrier. The agency wanted the back of the barrier to be radial to the slope of the deck. So whether it was a 2% slope or 3 or 4 or 5.5, whatever it is, they wanted that barrier to rotate with the deck surface. And we were able to use a couple of those construction lines very effectively to do that. All right, deck breakbacks. That's something that was implemented in OBM in 2022 release 1, so version 10.11. But if you're not using that version yet, whether it's for TxDOT or FDOT or some other agency, how can you do those deck breakbacks today? Well, today what you'll do is you'll overextend the slab if you need to from the start and end of the bridge, and then use the 3D solid modeling tools to go in and cut that template there. So here I've got a deck, a barrier, and then just a simple line that I've placed out here in the model. And I'm going to use the cut solid tool. It prompts me for what solid do you want to cut, where's the cutting line, and what do you want to keep. So I'll select the solid, select the cutting line, and then accept on the side of the element that I want to keep, and get that cleaned up very quickly. Deck elevations at a gutter line, or really any other offset for that matter. Maybe it's at a lane line or something else like that. You can use offsets over here in this field, and you can put multiple offsets in, just simply separate them by commas. So if it's relative to, let's say, the alignment or an edge of deck or the front face of a barrier or something, you can use these offsets, and we'll generate deck elevations along those offsets. Now, one other tip, in version 10.11, that allows you to define points in your deck template that can be used in the deck elevation report. So if we're looking at the deck template here, you can take any point and you can turn on this toggle now, this elevation report toggle. So when you go to do a deck elevation later on, that point name will show up in the list just like your alignment and your barrier faces and your beams and so forth. All right, how do we go about modeling, let's say, a gore on a deck, or you know, it's doing some kind of a taper or transition that isn't handled easily with the variables that we have today? Well, that's where our point controls come in. To any point on your deck template, you can assign a horizontal alignment, a vertical alignment, or both. All right. Just keep in mind, these are applied last as it's generating the solid for your deck. So it will override any variables that you have defined on your deck. So just be careful with these point controls. You cannot have any point on your deck template cross an adjacent point. All right. So let's say you can't have the right edge of deck cross the point at the profile grade line, let's say. All right. Or in simpler terms, don't cross the streams. Okay. Again, just like I says, good advice is timeless here. And you will get some kind of an obscure message if your point controls try or attempt to do something like that. So let's take a look at a quick little video here of using point controls. So you can see we've got a curved alignment here, but what the agency wanted at the end of the day is they wanted a straight bridge on a curved alignment. All right. So when I initially placed the deck template out here, it looked something like this. But then, and I purposely, I could have done the point controls as I placed the deck template. Just want to make sure everybody understands that. But you can always come back after the fact and do it at any time as well. So I have a line out here at the gutter line on both sides. So I'm going to tell it I want to add a horizontal constraint to P1 here. I select the 2D geometry out here and apply it, and you can notice it very quickly straighten out the right edge here. I'll do the same for the left side. So I'm going to tell it for point 11, I want a horizontal point control. I'll select a line. Again, those lines are civil geometry. They do have to be civil geometry, not just a generic microstation line. They do need to be civil geometry. But if you go back and modify that civil geometry at any time, that deck template will update instantly as well. How do we model sidewalks? I've seen a lot of different uses in the past, but honestly, the barrier tool is probably the best option. You know, unless it's actually poured monolithically with the deck itself. So, but if you're wanting separate quantities for it, then you're probably going to use the place barrier tool to do that. Now, starting in the 2021 release 2, we can place barriers on the sidewalk as well, on another barrier, right? So you can use the barrier tool to place this, and then you could turn around and place a barrier, let's say out here, relative to points 5 or 6 on this particular barrier. In the newest version, we can also place barriers on wing walls as well. How do we model expansion joints? Well, we don't really have a tool for that today, a specific purpose tool. So really, probably the two best possibilities are just as a 3D line style, or as some kind of a 3D functional or generative component of some kind. All right. Is it possible to model equipment, streetlights, signalization, inspections, catwalks, and so forth on a bridge? If you have a 3D cell, we have a couple of different tools out there that make very quick work of placing those relative to the deck. All right. So it will do it pretty much relative to the surface of the deck. It could either do it along the edge of the deck, down the median, wherever you like. So just kind of keep that in mind when you create that cell. set the origin on the cell relative to some key point on your deck there, and I think you'll be okay. Super elevation. This one actually came up on one of my calls earlier this week, but this slide's actually from a little before that. But we can assign super elevation to one of our templates. So if the roadway folks, typically when they compute super elevation on their project, they don't stop at the bridges. All right, they'll go from the beginning of the alignment to the end of the alignment, and they'll add lanes out there. Now, a lot of times their lanes won't match up exactly with points on your deck template, and that's okay. There'll be a little warning along the way, but otherwise it will apply that super elevation. And what it does in reality is it just adds to the variables that you have built into your template for the slope on the left or right side, or however many different lanes you have there. It adds stations and slopes to that table for each of those variables. Skew beam-ins. This one comes up from time to time, depending on the skew at a support. Some agencies may go in there and clip those flanges. So in our beam layout window, you can enable a skew ends toggle here and have us clip the end of the beam for you. Now we're going to do it for the full width of the girder. I have run into a couple of agencies where they may only clip, let's say, an interior flange, but not the exterior one or something. If you want to do half of a flange, a left or a right side, but not both, then you're probably back to the MicroStation modeling tools for now to accomplish that. Relatively recent addition is, and it's for some of those larger girders, whether they're Super Ts or some of these big U-beams and so forth, or box girders. How do you go about setting the number of bearings under each girder? So in the beam layout window, there's an advanced bearing definition toggle here that you can use, and it adds these columns here related to bearings. It can be any girder type, really. It doesn't have to be a box girder. It could really be any type of girder there. And then new to the newest version, to version 10.12 that came out this spring, they added transverse offset and longitudinal offset here as well. All right, beam spacing when the deck changes, width changes. All right, so what are we talking about here? So let's say you've modeled the deck, you did the beam layout, maybe even placed some beams, and then somebody comes back and says, "Oh, you know what? Instead of 40 foot wide, we need the deck 44 foot wide or 48 feet wide or something else." So you go in and you change the variables for your deck width, or you change your point controls to adjust it, and then all of a sudden all the beams move when you do that. Well, here's the thing: is when we do the beam layout, by default, the rightmost beam is placed relative to the right edge of deck. The leftmost beam is placed relative to the left edge of deck, and then all the other interior girders are, by default, relative to the leftmost girder. So if that left beam moves, if you change something about the width on the left side of the deck, all the other interior beams are just going to follow it along. When the spacing on those gets set, it's a snapshot in time of what is the width of the deck at this moment. There is no little toggle in there that says, hey, just keep them equidistant no matter what I do to the deck. But it's pretty easy to go in and modify. Just go in and open the beam layout window, and you can do one of two things. You can change the number of beams, maybe add a girder there and then take it right back out. There's a little button there to do that. Or you could go in and reapply the fascia beam distance there for the exterior girders, and that will force it to recompute the spacing of all the interior ones and equally space them between the left and right most girders. Okay. Advanced deck tool. What is it and when would you use it? Honestly, I hadn't really dug into this thing until earlier this year. Somebody was needing to model basically a kind of a cast-in-place box or segmental type structure, a very long one actually, with a lot of variations to it, had diaphragms, all kinds of things going on. Started playing with this tool and realized this is really powerful. So it can be used to place multiple decks along the structure. You can easily add diaphragms with it, and then all of your variable constraints are available to you as well. So this is kind of the resulting structure I was able to model. I was able to very quickly go in and add the diaphragms over all of the interior supports here. I was able to vary the depth of the box. And when you're using the tool, it looks something like this, the Place Advanced Deck tool. So first you tell it about all the different deck sections that you have. You can have one deck section for the entire length of the structure. You could have multiple deck sections. So let's say in the example of a cast in place box, maybe you have a custom, maybe you have 2 boxes for a while, and then it goes to 3 and back to 2, or who knows. By having multiple deck sections here, we can handle any of those situations for you. And then there's another tab here just to go in and add the diaphragms. And a lot of times those are relative to your support line. So those are real easy to go in and add those into this model. And then lastly, you have your variable constraints. So all the variables that are on all these different deck sections over here show up in this table. And whether it's the depth of the box or the width of the flanges or the thickness of these sidewalls, any and all of those could change over the length of the structure. So you just come in here and set those variables like you would with any other deck template. Cross frames, radial to an alignment or beams. Can we force these interior cross frames to be produced using the wizard if skewed supports are used? Because by default, it'll do it parallel to the first support. But with these position lock buttons, you can force it to be normal to either the left or the right girder within the bay there. So that's how you're going to get these to be radial to any of the beams out there. All right. Can we force it to have a horizontal cross frame? If you're doing steel cross frames or diaphragms on precast girders, then the answer is yes. There is an option here to force those cross frames to go in level, so basically truly horizontal to the world there between the different girders. For steel girders, there is a vertically center option if you're using a diaphragm. All right, so we can vertically center those. And there's also a new option when you're defining the cross frames, and I didn't include that on here, but you can tell it, instead of using the top or bottom of the cross frame, you can do it relative to its center of gravity, which is a new option. So next one here, built-up diaphragms. All right. Didn't find a built-up diaphragm in the cross frame option. Is there a way to have that added to the shape? So that's a relatively new functionality of the software, is to use a bent plate diaphragm here and use that as your diaphragm for either precast or steel girders. Corbels on the abutments. Can the corbel, so we've had corbels for a couple of versions here, but then the question came up, can that follow the slope of the approach slab? Yes, if you're using at least version 10.11, after you place the approach slab and you have a corbel on your abutment here, you can go back to your abutment and you can turn on a toggle in the properties there, make corbel or place corbel with approach slab bottom true or false. So if you set that to true, then that corbel will be crowned similar to the approach slab that it is underneath. All right, build order. This is something we're probably going to be kind of minimizing going forward, but it is still there in the product. It's primarily used with our OpenBridge software, our analytical software. as it does allow you to define an unlimited number of construction stages in the RM software. So this kind of, if you were to model a bridge and send it to RM, this build order goes over with it. Irregular footing shapes comes up more and more often these days. Is there a way for OBM to support any of those irregular footing shapes? Yes, we can. So in the 2022 release 1 or version 10.11, we added a new footing template library that allows you to define really any footing shape you want. It's a 2D library, very similar to the deck libraries and barrier and beam libraries. Even goes into the same XML file for that matter. But you can define any shape that you want here. You could have variables on it if you needed to, but you can also define the location of any and all pile when you create this footing shape here as well. So again, pile locations can be defined. You can, and it just has to be a generic location. You don't have to specify the type of pile at the time that you create the template. It's simply a location within the template. When you place, when you use this in a pure template, at that time you can tell it what type of pile do you have and their dimensions and their batter and all that good stuff. Parametric cells, or for that matter, even generative components. They're really going to be about the same thing here. So those either parametric cells, functional components, generative components, whatever you want to call them, can the bearing pads from OBM react correctly to those? Only today, only in the case where there's no slope or the slope on the deck is constant from one side to the other. If you have a crown deck or anything else other than a constant slope all the way across, the bearings are placed assuming a level cap. All right, it doesn't really have the ability to read the top of the cap from those functional components today. Barriers. Why are my barriers look odd? This came up twice last year. Two completely different companies using completely different barriers within about a week of each other had reached out to me and had something like this. And what we figured out for both of them, thankfully, was we just went in and changed the chord tolerance. The default chord tolerance is really very large for these barriers. So we went in and dialed this down to about 0.1 and 1 here, and it cleaned up this wavy look right away. I couldn't really figure out anything specific to the deck template or the barrier template or the profile grade line or anything else that forced it to do that or caused that to happen originally. But the default max distance between sections is something like 15 feet or larger. So by setting that smaller, it cleaned it right up. Deck drains. How do we go about modeling these along a bridge? They can be placed as 3D cells, but it would still be up to you to go out there and cut out the deck with the solids modeling tools to really get it to stand out and look really nice. Same kind of thing with slotted drains or slotted barriers here. Can we place them? Yeah, you can. 3D line style is an option if it's just purely for visualization purposes like this. You could have a cell that you place along here. The trick with the cells is you only get one origin point, so getting it to follow the grade of the deck or be parallel to the grade of the deck is a little trickier. But I have seen lately some folks developing GC and doing some pretty amazing things with any kind of barrier, whether it's an open barrier like this, or I've seen some other very unique barrier shapes, let's say, that weren't even concrete barriers. They were something else, but turned out looking really impressive in the model. Steel railing. How do we go about modeling steel railing on that maybe sitting on a barrier here? So So it really, again, depends on your level of detail. Relatively low would be a 3D line style. Although I do have to say, the 3D line styles that some of our MicroStation folks have created for our users have been really impressive. I kind of hesitate to call it a low level of detail because they have been really nice. Again, you could use a 3D cell, just like the slotted barriers, and use that with the place path tool. Or if you need your highest LOD, that's going to be using ProSteel. Go in and enable the Pro Structures license within OBM and use the ProSteel tools to go in and model that. This one came up, I think it was just earlier this week or last week. In the quantities report for steel beams, somebody came back and said, you know what, in the first and third spans of my structure, I've got the exact same lengths of span, I've got the same flange sizes, same everything else, but the quantities are different. Why is that? Well, what we figured out is even though the beam sections are identical, since the grade of the structure is different in those two spans, it took into account the true length of the girder, not the section length as it was defined. And so I just did a quick test on my own. I just used the bridge wizard. I went in and modeled just a simple bridge there. And when it does it initially, it's always at a 0% grade. So I ran the quantities report on it. I got these three values. And then I went in and changed the grade on the bridge to a 3% grade. And I got slightly larger values as we come to expect. So it does use the true length of those elements because we do read the volume of those steel plates from what MicroStation tells us is the volume for the webs and tops and bottom flanges. And that helps us come up with a poundage of steel for each of those members. Another one, happened to use this yesterday, but does come up quite a bit. How can I go about checking stations, offsets, and elevations of points in my model? I'm not used to working in 3D here, or maybe I'm used to using an older Bentley product for this, like Inroads or Geopack. How do I go about checking these things? On the civil tab here, there's a civil analysis tool that will let you go in and pull that information very quickly. So you just pick Analyze Point here, and then it asks you what to analyze. This will work with terrain models, corridors, alignments, whatever. So I just go out, select an alignment, and then when I snap to a point, notice it gives me station, offset, gives me an XY. It also, we didn't quite see it there or quite get time to see all of it. But also gives you an elevation, a slope, and a direction, and even the radius of the curve here at this instantaneous point as well. So it does give you a lot of information back on that. All right. Question regarding the OBM Smart Solids. If you decide to trim those up, is there any intelligence lost? What happens with the elements and so forth? So let's say if you had a corner of a skewed deck is cut, the quantities before and after are compared, the deck quantity is updated correctly. And I've had that true for, let's say, piers. I've had folks go in and modify a footing prior to us having custom footing shapes in that. And since we do read those elements from MicroStation, most of the quantity reports that I've worked with anyway have been correct. They've honored any of those manual changes that have been made. But just be forewarned, if you go back and let's say after you do some deck breakbacks by hand, and then you go back and modify some variables on your deck template, it's going to delete and redraw that deck, and it's not going to be aware of any clipping that you had done to that model after the fact there. Okay, so here's an example of a deck prior to doing the solids modeling cut, and then here it is after the cut with about 2 yards less of concrete there. All right, for those of you that use OpenBridge Designer, okay, let's say you want to pass a parameter to OpenBridge Modeler at startup. You can do that. You would have to go into the target line here. You maybe right click on the icon and go to properties. And in the target down here, you specify, you just put in OBM params equals, and then whatever you want to pass to the modeler when it gets opened from the designer product. So Connecticut DOT, for example, they pass it the name of their workspace and the user configuration to use there. You could force it into a debug mode. I've had to do that in the past when I'm creating workspaces and I'm trying to figure out why something isn't working right. It works well with the restore defaults command. If you're not familiar with that, go out and Google MicroStation restore defaults. That will go out, and when you launch a MicroStation-based product, the dash restore defaults tells it to go out there and clean up about 4 different folders that have a lot of temporary files in them for you very quickly. So really, really handy. Or I had, this one came up last week. Somebody emailed me and said, hey, I'm using Designer. I'm testing out some generative components that have been created. How do I force Designer to launch GC for me? So I was able to go and I just use this OBM params equals GC equals 1, and that was able to do it for me. Very quickly, I got about 2 minutes left here. Little known used variables here. One of the ones you can enable is OBM skip reference schema check. It's off by default, but if you set that variable to true, you won't see this information anymore, because a lot of times you're referencing ORD files that might have been from an older version of OpenRoads than the OpenBridge software that you're using today. You know, whether it's a geometry file or a terrain model or a corridor. It recommends you go in and upgrade them. Problem is, well, we can't open those files with OpenBridge. And so you may not want to see this coming through. So if you set this to true, you don't have to click through this anymore when that comes up. If you're not using ProStructures and you want to disable it and keep all of your other users from accidentally enabling it and consuming a license also, you can set this variable to a 1. It is enabled by default, meaning ProStructures is enabled. You can use it, but if you want to kind of hide it, you set this equal to 1, and you'll notice this ProStructures icon that we see on the left with this enabled goes away in this case. Cross-frame decorators. So the 2D lines that are drawn, anytime you have cross frames that represent your stiffeners and cross frames, there's a simple little variable that's been around forever for setting the spacing between those elements. OBM bearing line to support line ratio. This came out just 2 or 3 versions ago. It's disabled by default, but if you set it, the default length here is 7/10 of the length of the support line. That's how long the bearing line will be. So instead of them being the same length all the way out, you can shorten those bearing lines up a little bit. The dynamic view settings file, this is used with is used by the substructure and typical section tools here for those drawing tools. There's a settings button here, and all the settings that we see here in this window can be saved off to an XML file. So things like your default dimension styles and default levels for your dimensions and that can all be predefined for the user, so they don't have to do those. Lastly, SPC filters. So these are for things like your cross frames and your H piles and your connectors and that. What country codes do you want the software to be able to access on the way in? By default, we just have the AISC code in there. But if you look at our OpenBridge Modeler config file, you'll see a lot of other countries listed in there, but commented out. So if you want to use them, just uncomment the ones you need, and you should be good to go.